Thank you all for coming. My name is Becky Rom. I'm the National Campaign Chair for the Campaign to Save the Boundary Waters. Can you hear me? Well, this is, let's see, I don't think there is a microphone here, so I'm just going to have to shout. If you can't hear me, wave your hand. I'm delighted to be talking to you tonight along with Dr. Lee Freilich. Dr. Lee Freilich is the director of the University of Minnesota Center for Forest Ecology. He received his PhD in forest ecology from the University of Wisconsin-Madison in 1986. He teaches forest, fire ecology, and landscape ecology on the St. Paul campus of the University of Minnesota, and he has advised 25 graduate students. Dr. Freilich has authored more than 140 publications with 120 co-authors from 15 countries, including major works for Cambridge University Press and Oxford University Press. He is listed among the top 1% of all scientists in the world. His research has been featured in the media 400 times, including venues such as the New York Times and the National Geographic. Dr. Freilich has provided consulting services on forest management for many government agencies, including the U.S. Army, the Air Force, the National Forest Service, the National Park Service, and the Departments of Natural Resources in several states. Current research that he is working on includes fire and wind in boreal forests, old-growth hemlock, and in hemlock and maple forests, invasive earthworms in forests, deer and moose browsing, patterns of tree height, and impacts of climate change. So he does a lot of diverse research. His area of specialty is the Quetico Superior ecosystem. So we're extremely fortunate to have him with us today. This afternoon he gave a talk on his work on climate change and invasive species. This evening he's going to talk about some of the science that's associated with proposed sulfide ore copper nickel mining in the Rainy River drainage basin. I'm going to start and talk about a few things and then turn the program over to Dr. Freilich. This program is intended to introduce you to some of the science around this ecosystem and around sulfide ore copper mining. It is not at all exhaustive. There's a lot of science out there that we're not touching on, but this is the science that is relevant to certain sulfide ore projects that are proposed in our drainage basin. Science and the effects of this proposed activity affect natural resources like land and water and the wildlife that lives in there. That's what this night will talk to you about to some degree. It does not talk much, but a little bit, on human activities. So there's a lot of human activity that also goes on in the Superior National Forest and in the boundary waters. And for another day, we'll talk about how a change of our landscape in the Superior National Forest from a very healthy, well-managed national forest that serves a lot of purposes into an industrial mining district, how it would affect a lot of other issues. What would its effect be on the local economy? How much money stands to be made or lost? In whose hands will the money fall? What will happen to all of our activities that the land currently supports, such as timber harvesting and resort use and other economic activities? Recreational uses such as hiking, snowmobiling, that sort of thing, or subsistence activities like hunting and berry gathering and fishing. This talk will also not talk about the impact of a change in the landscape on people's experiences and sense of the place. To many of you who are in this audience, you live here for a reason, and that is to be able to experience the great wonder of our Superior National Forest and our boundary waters. That's why we're the most popular wilderness area in the country. So a lot of topics. We hope to cover many of those and as we go forward on this journey. And tonight we're going to focus on some aspects of science. This program is brought to you by the Campaign to Save the Boundary Waters, which was founded by local people in this community, people who work here, own businesses here, and live here. And it has grown into a coalition of national organizations who are very concerned about the proposed changes to our landscape, proposed changes to the Superior National Forest with the goal of protecting permanently the Boundary Waters Canoe area. Specifically, based on the science and a lot of other work, we're opposing twin metals mine proposals and other sulfide ore mine proposals in the watershed of the Boundary Waters to protect this great area and to protect, among other things, our sustainable and stable economy. What makes this place so special? The Boundary Waters Canoe area is large. It's 1.1 million acres of protected wilderness area. It's actually been managed as wilderness since 1926, which is very unusual. It's been managed as wilderness longer than any other place in America, save one. It's the most heavily visited wilderness area in the United States and has been for 50 years, every single year for 50 years. It's the only significant lakeland wilderness in the country. It's the largest wilderness east of the Rocky Mountains and north of the Everglades, and includes a large variety of canoe routes, hiking paths, and designated campsites. The areas impacted would go beyond the Boundary Waters, and they would include the Voyageurs National Park and the Quetico Park. Voyageurs National Park is also special. It's a national park. It also receives many visitors every year, nearly 250,000, and it's popular for boating, fishing, and wildlife watching. It, like the Boundary Waters, is a mosaic of land and water, and it has a very significant historic landscape. These national treasures are in the Rainy River Drainage Basin, which we'll talk about. The Boundary Waters at 1.1 million acres is within a 3 million acre national forest. The national forest is part of a national forest system in the United States of 190 million acres. Our national forest has 20% of the fresh water in the entire national forest system in the United States, and it is the most pristine. We also have a wilderness edge economy. This is the heart and soul of our local economy. In northeastern Minnesota, according to the IRRB, tourism supports 18,000 jobs and brings in $850 million in sales. The Superior National Forest alone brings in $500 million, a big chunk of that of which is supported by the wilderness. And a lot of wilderness edge businesses operate out of Ely, plus other areas that would be impacted, such as Sawbill and the Gunflint. What we have found, based on the best research in the country, which is the Federal Reserve Bank out of Kansas City, that northeastern Minnesota has the best characteristics that can be had for rural communities for a successful economic future. Number one is great natural amenities. The Boundary Waters Canoe Area Wilderness, the Voyageurs National Park. It also has, the 3 counties of the Arrowhead, rich entrepreneurial context. We perform better than 70% of the counties in the state of Minnesota. And we also have an abundance of creative people. We do better than half the counties in Minnesota. The driver, of course, is the Great Boundary Waters, the Superior National Forest, that support that great outdoor natural amenity. This would be at risk. The threat is from twin metals and other mining companies that propose to put mines on the edge of the Boundary Waters and in its wilderness edge communities. This is a type of mining that has never been done before in Minnesota, and its risk is that it would permanently ruin the pristine waters and our unspoiled forests of the Boundary Waters Canoe area that is so valuable to this community. It's always toxic. There has never been a sulfide ore mine in the United States, or in the world for that matter, that has not polluted water, groundwater and surface water, rivers and lakes. This is because of the nature of this type of mining, which is very different from taconite mining. It is much more toxic than iron ore or taconite mining. These rocks contain sulfuric acid. When snow and rain fall on these types of rocks, what flows out is not water, but sulfuric acid, and it leaches out with it heavy metals and sulfates, all of which are damaging to the environment. The waste piles from mines in this location would be huge. Less than 1% of the ore body contains metals such as copper, nickel, platinum, and palladium. So over 99% of the rock would be waste. An industrial mining district, I want to do a few minutes on a University of Minnesota Morris 4 township survey. And from that we'll transition into the science. The University of Minnesota has a Center for Small Towns, and among other things, it surveys people who live in rural communities to find out a lot of things about the community. In 2014, it issued the results of a survey it did that covered the 4 townships around the Ely area. And it's a great report. I encourage you to read it. It is in its entirety, and I've just pulled out a few things to talk to you about. Residents of the 4 townships were asked why they live here. The top 7 reasons all related to nature. You can't really read them, but they live here for the nature, environment, and wildlife, solitude, privacy, beauty, peace, quiet, recreation, the boundary waters, they enjoy the area, and quality of life. What would make you leave this area? 23% they'd leave if mining came. 21% they'd leave because of pollution, and 17 said they'd leave because of overdevelopment. What types of developments do you support? The top 4 were recreational commercial, residential, non-mining industrial, and non-recreational commercial. Less than half supported mining or extraction development, and that had the highest opposition in the 4 townships. They were asked where these activities could take place. Less than 2% said it was okay to do this on the shores of rivers or lakes. This mining is proposed on the shores of Birch Lake and the South Kawishwee River. People were asked what types of jobs would you like to see expanded in the region. They were given 14 choices. Only 35% chose mining. Outdoor recreation was the top. Technology, wildlife management, forestry were in the top. People asked if they were employed and what their employment status was. A lot of them are retired, 51%. 44% were employed, not searching for a job. 2% were employed but searching for a job. 2% were unemployed, not searching for a job. Unemployed and searching for a job, 1%. People were asked, if you had a job, what would you like to do? Education and health services was number 1. Professional and business services was shortly thereafter. And so, excuse me, I said what you'd like to do. This is what you currently do. So most people are in education, health services, professional business, construction, manufacturing, outdoor recreation, leisure, and hospitality. Interesting, mining was 5%. Those are the commuters to the taconite range. And logging was at 3%. So it's an interesting slide of what the people do in the townships. Now I'm going to turn to the proposed mine so you'll understand what Lee is talking about. What you have up here is a map. The top of the map, sort of on the right, is the Quetico Provincial Park. Immediately underneath it, labeled, running along the Canada border, is the Boundary Waters Canoe Area Wilderness. Over on the top left is Voyageurs National Park. The colored boxes represent mining activity currently going on in what you'll see in a better slide is the Rainy River Drainage Basin. So you know we have a continental divide. We actually have 3 in northern Minnesota. This is the continental divide that is called the Laurentian Divide. It's a squiggly line. All of the surface waters north of the squiggly line in the Rainy River Drainage Basin flow north. They go into the boundary waters, into Quetico, into Voyageurs National Park, and they head down to the Arctic. We're limiting our talk to the Rainy River Drainage Basin north of the Laurentian Divide. This is a close-up. The colored boxes represent areas in which mining companies are currently doing prospecting of various types. It's hard to see on this map, but and I had a pointer that doesn't seem to be working, unfortunately, but where Gabriel Lake is, and you see the word Spruce Road, the South Cowish River exits the wilderness at that point. It starts deep in the wilderness at Cowish Lake, splits into the North and South Cowish River, and exits. And it runs along the spine of the colored that shows the mining activities, where it meets up with Birch Lake. Birch Lake starts down in the left-hand side. You can see Birch Lake, and curves around to where it meets the South Cowish River right at a site called Maturi. They meet there, and then they flow north into the Waikola chain and into the boundary waters at Fall Lake. Twin Metals has 4 deposits it's identified in its mining concept plan, and they're labeled on this map. Spruce Road is 1. It's outlined in blue. At its closest point, it is less than a half a mile from the wilderness, and streams in the Spruce Road deposit flow directly into the wilderness in the Gabriel Lake area. That is a very shallow deposit. You can go down the Spruce Road and walk the site. There was a bulk sample taken from that site 40 or 50 years ago, and the mound where the bulk sample was taken is still barren of vegetation. It's easy to find. That deposit is mineralized to the surface. The only mine plan that was ever done for that deposit is an open pit one. That's a very old mine plan. Twin Metals has not told us what they want to do with this deposit yet. Going down the South Cowish River, you see the Maturi deposit. That is a deep deposit. The way the sulfide flew through the gabbro rock, which carries with it the metals, was like lava, that sort of thing. And so these deposits go shallow, deep, shallow, deep. Maturi is deep. Across from Birch Lake, from Maturi, is Maturi Southwest. That's a shallow deposit with mineralization to the surface. And then south of there is Birch Lake, which is a deposit under Birch Lake. Those constitute the 4 deposits identified by Twin Metals. This is a map that shows you all the different companies that are working in this Rainy River Drainage Basin. So it's not just Twin Metals, it's a number of mining companies. Every color scheme is a different company. This map shows you the drilling that's been going on in the Rainy River Drainage Basin. It's organized by color according to the year, but you can see that they follow the front end of what's called the Duluth Complex, but follow the South Cowish and the Birch Lake for quite a ways down the map. So you can see there's been a lot of prospecting. It's been going on very close to the wilderness. There have been significant reports of disturbance in the wilderness over the last 10 years while this drilling has been going on. This is the concept plan, the mine plan for Twin Metals, which is what we gave all of our scientists who've looked at this issue. So you can see the Spruce Road deposit in red at the top. The Maturi deposit is down on the South Cowish below that. And then you see Maturi Southwest coming further down on the shore of Birch Lake. And then the Birch Lake deposit is a southerly deposit. So the mine plan at this point includes Maturi Southwest and Maturi. Maturi Southwest is proposed to be an underground mine. It will be accessed from a 1,000-acre site on the west side of Birch Lake. That's where the tunnels will start, the processing facility will exist, and where waste piles will exist for quite a few years, 27 years at least. There will be tunnels that access the Maturi. Maturi Southwest is just below that. It shows a tunnel. The mine plan says it will likely be mined to the surface. They're planning to mine within 15 feet of the surface, and that overburden will likely be taken off. They're planning to put roughly half of the tailings, the waste, south, and so there is a long pipeline that's in pink that takes you from that 1,000-acre processing site down across Birch Lake, or under Birch Lake, to a 7,000-acre tailings site, which is south of Birch Lake, north of North Shore Mining. So that's roughly the mine plan. On top of the Maturi deposit, there will be a complex of paste plants, and also at Maturi Southwest, and that's a means by which you can convert tailings into more of a cement-like structure and return it down under earth. Now this is the location right now. This is an aerial view. You're looking at the Boundary Waters Wilderness in the background. The South Kawishwe River is flowing out of the wilderness down towards you. Up in the background on the this side of the South Kawishwe River is Voyager Outward Bound School. If you know where that is, that'll help you locate it. And roughly across the South Kawishwe River from there is the Spruce Road deposit. You come down closer, many of you here know Jane and Steve Kuschak. They own River Point Resort and Outfitting business, third generation owning it since 1944. They're right here at the point where South Kawishwe River meets Birch Lake. Down on this shore of Birch Lake, right over here would be the 1,000-acre processing site where the industrial activity goes on. Maturi Southwest would be further down the shore of Birch Lake. If you know where the federal campground is on Birch Lake, it's immediately adjacent to that. So that tells you the place where Twin Metals, one of the mines, proposes to start its mine project. There are at least 33 businesses in the path of pollution that are located in this area, Birch Lake, South Kawishwe River. They're resorts, outfitters, camps and campgrounds, and between Birch Lake and Fall Lake where the likely polluted water will flow back into the wilderness. That's over 40% of the businesses listed on the Ely Chamber of Commerce website, and they'll be in the middle of this industrial activity. This is the Rainy River Drainage Basin. This is the basin we're concerned about because some of our most valuable national public lands are within this basin. The Boundary Waters Canoe Area Wilderness and Voyageurs National Park. Quetico is also in this basin, and the Canadians are very concerned about the impact of any proposed mining in this basin on those areas. The Boundary Waters Wilderness is off limits to mining. In 1978, Boundary Waters Wilderness Act banned mining in the wilderness. It also banned mining outside of the wilderness in the area that is crosshatched. That's a mining protection zone. And it covers on the right-hand side the Gunflint, the Fernberg area, the Echo area, and the crosshatch under the Trout Lake unit. It's 220,000 acres in size, and mining is banned. No mining on federal land, no mining on any other land if the mining would impact navigable waters. So that sets the stage for where we are now. The federally owned minerals in the basin that are not in the banned area are colored in yellow. And so it's the mining in that yellow that we're going to look at tonight to see how mining there might impact the wilderness. With that, I'm going to turn this over to Lee to talk to you about the science of the ecological work that has been done.
I'm going to talk about the science of how this type of mining affects the water quality and then how that feeds back onto the ecology of the sites. So talking about hydrology, we had Tom Myers, who's a hydrologic consultant, from Nevada, and he did 4 reports for us about how the chemistry of the water could change, what the flow path would be for any leakage, acid mine drainage that might get into the ecosystem. And so I'll rely on those when I get to the results here. So the current conditions in the boundary waters, it's outstanding resource value. It's one of the most pristine water resources in the country. It's the highest designation in Minnesota. There's relatively acid soils in most of the area. However, the water is pretty well buffered against natural acidity that comes from the ecosystem, but it's not very well buffered against acidity that would come from mine drainage. There's no carbonate, for example, in the water. Carbonate is a chemical that would neutralize acid coming from acid mine drainage. That's non-detectable in these waters. So lack of carbonate and a low pH indicates that it has a very poor buffering capacity. So basically there's no capacity to buffer any of the acid that would come from acid mine drainage, which would mean that the effects could go quite far downstream. And then we have varying levels of lakes throughout the year. There are very low flows, and the problem with the low flows is that any acid mine drainage would be very concentrated in the water because there isn't much water there. This would be during droughts, and it might also be exacerbated during times of drought in the future. When we have a warmer climate, we could get some very long periods of low flow. So where does the acid come from? Well, there's a lot of sulfide in the ore, and when you expose that to air and water, it becomes sulfuric acid, and that's what acid mine drainage is. There's also the sulfate itself, and there is also the seepage that can come through, and it might come through in a year, or it might take a long route through the ground and come through 10 years or even 50 or 100 years later. And the longer it's delayed, the longer generally it will continue to flow. So the contamination threat here is that there's a high metal concentration in the seepage. There's mercury already in the system, and that mercury is coming from fossil fuel burning over the last several decades. That's inert in the system. It could be reactivated by the chemicals coming from the mines, and then there's poor buffering in the water. So those are the 3 issues. And according to Tom Myers, who wrote these reports, it's not a question of whether, but when a leak would occur. And some of this acid mine drainage would get into the ecosystem and affect the boundary waters Canoe area. So these are the paths of flow, and you can see there the gold boxes, which are where the mineral leases are, and then you can see in the brown the paths that any acid mine drainage would flow through. So it would go into the boundary waters and then along the international border route and eventually over into Rainy Lake at Voyageurs National Park. A little bit of a close-up view here showing that if some of those leases a little further to the east were mined, then there would also be several flow pathways into the wilderness. And again, it would go through Fall Lake and up to through Basswood Lake into the international border route. If there was mining at Lake Vermilion, that would also drain through into the Rainy Lake basin at Voyageurs National Park. So what do all these reports indicate? What about the aquatic ecology? Well, we had Lawrence Baker, who's a professor and biogeochemist at the University of Minnesota, write a report about that. So what effects there might be on fish and aquatic plants. So it only takes a little bit of a drop in the pH because it's a logarithmic scale to really change the fish communities a lot on any drainage pathway that would have any acid mine drainage. So lake trout and walleye could be lost just from 1 pH unit, just going from 6 to 5, and with no buffering capacity in the water, that's something that could easily happen. And that would have cascading effects, of course, on other wildlife, such as loons that eat the fish. Then we have the sulfate issue. And there are three things going on there with sulfate, which there's a lot of in this ore. One is eutrophication, which is basically over-fertilizing the water and having blooms of algae. And what's going on there is phosphorus is the limiting nutrient in these waters. And when there's sulfate present in the water, it causes a chemical reaction that releases that phosphorus from the sediments in the bottom of the lake. It's been gathering there for thousands of years, and that can fuel the growth of algae. Wild rice is also sensitive to sulfate. There's a fair amount of natural sulfate in these waters, and it's just a little bit below the threshold that wild rice can tolerate. So adding just a little bit of sulfate could bring it up to that threshold where wild rice would no longer grow. And then there's the mercury issue, and as I mentioned, mercury is already in the sediments. It's in our soils, forest floors, it's everywhere because it comes from burning coal. There's a little bit of mercury in coal. We've been burning coal in fossil fuel power plants for decades. It goes out through the smokestack. It's carried tens to hundreds of miles across the landscape, and it comes down in precipitation, becomes part of the sediment. Well, it's in an inert form, but if there's any sulfate in the water, that causes a chemical reaction that converts it to methyl mercury, which then can become part of the food chain. So fish could have mercury in them, and then loons could have mercury if they eat those fish, and it would be concentrated by an order of magnitude at each level as it goes through the food chain. So the summary here is we have acid generation, there's direct toxicity to fish from that, and their prey below a pH of 6, walleye would be lost, and that's a tiny step from where the pH of these waters is now. To go down to a pH of 6, we get the heavy metals, mercury and so on that can impact fish and their prey. They can also impact caddisflies and other insects in the water. And then we have the sulfate impacts that I just covered with the eutrophication, the wild rice effects, and the mercury methylation. When you add all these together, you get a cascade of effects on wildlife throughout the ecosystem. Okay, and then my specialty here, forest ecology. So I wrote one of these reports that is being used to put this presentation together. And by the way, what I say is mine, and it does not represent the University of Minnesota. So if you don't like what I say, blame me. Don't blame the university, okay? So, primary effects on the forest, and you might think, well, what effects are there going to be on the forest? Well, you have the direct footprint of the mine where the forest is removed to build the mine, the tailings ponds, the lines, the pipelines, parking lots, roads, all of those things. Some of the impacts of having acid drainage or acid dust. You can get actually dust from these systems that blows away into the forest, and it can blow for a few miles into the forest. If you get acidity going into the forest, you get loss of calcium, and that causes aluminum toxicity for trees. There's a balance between calcium and aluminum. Trees need calcium, they don't need aluminum. If you put anything that's acidic in the soil, the calcium leaches away and aluminum takes its place. The trees take up that aluminum and it becomes toxic. So that's the chemical reaction you get in the soil, just like you have the chemical reaction releasing the phosphorus or the mercury in the water. Disruption of mycorrhizas. Now there's a big word that a lot of people don't know. Mycorrhizas are actually extremely important in ecosystem function. In other words, the forest can't grow without mycorrhizas. And before you start throwing tomatoes at me, maybe I should tell you what they are. They are fungi, little thread-like fungi that are barely visible. Some of them are microscopic that live on the roots of trees. And all trees in the world require mycorrhiza, these fungi, to live on their roots. And what they do is they take nutrients out of the soil and give those nutrients to the tree. The tree in turn gives those fungi some food that it's manufacturing up in the leaves. So this symbiotic relationship is absolutely, it's one of the most important functions in the world. All the forests in the world would not be able to grow at all if there wasn't mycorrhizae. Well, these fungi are very, very sensitive to pH and any change in the chemical nature of the soil. Forest fragmentation is another issue. I've got several slides coming up on that. It happens to be one of my favorite issues. Another one here that I'm going to touch on briefly before I get to fragmentation is accelerated ecosystem aging. Did you know ecosystems age? They don't age very fast. They age over 10 or 20,000 years, and they slowly become more acidic just due to the production of natural acids by the trees and plants in the ecosystem. And so if we waited several thousand years, all of our forests would turn into black spruce bogs. You know, low productivity, thick moss layer, soaking wet all the time, not very productive sites. Well, if you add acidity artificially, you can accelerate that aging process, and instead of it taking thousands of years, it can take place in just a few years. So there's whoa, what happened here? I'm not sure what happened. I pushed the same button and the same thing did not happen. And they say computers are consistent. We're getting there. There we go. How do we make it full screen? See, I don't use this type of computer. That one, maybe. That one. Oh, there we go. Okay. I was just about to make the point about the massive interconnectedness of the aquatic and terrestrial system, the land and the water in the boundary waters, and these pictures illustrate that. Every square mile of land in the boundary waters has tens of miles of forest versus water interface or forest versus swamp interface. So there's this massive interconnectedness so that anything that happens in the upland system will happen to the water, and what happens to the water will happen to the land because they're so intimately connected. This means that the acid mine drainage, if it occurs, can flow all through the forest because it's like a sponge sitting on top of bedrock that the trees are rooted in, and it can flow back into the water way downstream. And so the exact routes that acid mine drainage might take on a small or local scale are not predictable, but there's massive interconnectedness, which assures that there would be a pretty big impact of acid mine drainage. And so this little diagram shows how our wetland forests are organized. So way over on the left side, you have those very poor stunted black spruce. They're at low pH. And then in the middle, you've got black spruce and tamarack that are big trees. That's where you have a pH of about 6. The stunted black spruce would be 4 or 4.5 in terms of pH, which is a measure of acidity. And then as you come further toward the right, you've got cedar and tamarack, and those have a pH of 6 or 7, quite high in pH. And then finally you get into the ash swamps on the right side here, which are quite high in pH. Well, all of these wetland forests are on muck, which is like a sponge sitting on top of the bedrock. And there's water flowing through it. And again, if there's acid mine drainage in there, it changes the pH. All of this whole gradient will be destroyed, and it'll push it all to the left end, which is the stunted black spruce. Okay, now let me get to the really fun one. the secondary impacts and fragmentation of the forest. This is the impact that's guaranteed to happen when the mine is built. You're going to build roads, there are going to be pipelines, there's going to be the footprint of the mine itself. It's going to fragment the forest. When you fragment the forest like that, there are noise issues, there are light issues, which are problems for wildlife. There's a heat island effect, just like there would be in the parking lot of a big shopping center or in a city. There are invasive species that take advantage of fragmentation, thistles, buckthorn, purple loosestrife, lots of different species of invasive plants are capable of taking advantage of a fragmented forest. Their whole growth pattern is ideally suited to those edges that are created. Road salt would be an issue because things would be driving around all the time, and you'd have to, you all know what it means to try to keep roads clear of ice in this climate. There are already trees being killed by road salt around the area. White pine on Passy Road, for example. White pine's the most sensitive tree to salt. So there would be more salt going into the water as well as flowing again through that spongy soil sitting on top of the bedrock. And these effects will go well beyond the primary footprint. Fragmentation effects are known to spread many miles beyond the primary footprint where the fragmentation actually takes place. And biologically, fragmentation just means you chop up an area. So in the lower part of the diagram there, you have the same acreage of forest, but it's in 3 different tracts, and it has a lot more edge for the same acreage. That's the basic ecological impact of fragmentation. And what does it mean? Well, if you fragment a landscape, generally the deer population goes up. If you have more deer in this area, you have fewer moose, because deer carry a brainworm, which does not kill the deer but does kill moose. So deer populations go up when you fragment the landscape, moose populations go down. Lynx have travel corridors right through the area where the mines are proposed to be built, so their travel corridors could be disrupted. Earthworms are an invasive species in this part of the world. Of course, moving hundreds of tons or thousands of tons of soil about the landscape means earthworms, invasive earthworms would be moved about and introduced to new places. And the spread of weedy species like red maple, I mean, everybody loves red maple, right, especially in October. But it's a very weedy tree. It's not good for timber. It's not very good wildlife habitat. It only makes a fraction of the syrup of sugar maple. It loves fragmentation, so it would be poised to spread very rapidly in a fragmented environment. If you have more deer due to the fragmentation, they like to eat oak, white pine, white cedar, yellow birch, yew, and many different species of native plants are eaten by deer. So that then becomes a problem for those regeneration of those tree species, and it can be spread 5 or 10 miles away from the fragmentation. And then invasives, buckthorn, garlic mustard, honeysuckle, all of these things. Canada thistle's a very common one in this area. They all respond to fragmentation. They're dispersed along the edges, they grow along edges. And with a very large fragmented area at the edge of the wilderness, we could have a buildup of a massive seed source that could put what we call propagule pressure or seed rain pressure into the wilderness for these invasive species. And that again can extend many miles away from the fragmented area. And here's buckthorn in northern Minnesota. For those of you who don't think it'll grow here because the climate's too cold, it's not true. It is in the Ely area. It will grow on rock, as you can see there. Fragmentation also affects seed dispersal, and some trees have really good dispersal, like oak, and here you see a blue jay picking an acorn, and they can fly up to 2 miles with them. So oak doesn't care much about fragmentation. With the help of blue jays, they can jump right over the fragmented area. But other species of trees, like white pine, are not so well adapted to fragmentation, and lots of native plant species are not adapted to fragmentation at all, especially lichens and fungi and mosses and smaller wildflowers, which may not be economically important, but they're very important for the function of the forest. Fragmentation also favors edge species among the animals. Brown-headed cowbirds, for example, is a species of bird that lives on edges of woods, and they don't build their own nest. They lay their eggs in another bird's nest, and so they parasitize other birds, especially songbirds. Various species of warblers, and here you see a cowbird egg in with two warbler eggs in a nest, and so they actually lower the success of our native songbirds, which are, believe it or not, very important for forest productivity. For a reason that has to do with what they eat, those small birds eat lots of insects, and there have actually been studies done showing that whether songbirds have access to trees or not means a 25% difference in growth. In other words, with the songbirds, trees will grow 25% more. Because the birds are eating the bugs that would eat the leaves of the tree. So you fragment the landscape, you get more cowbirds, you get fewer warblers, and the trees won't grow as well. And that effect can extend miles away. You can probably tell by now that ecological cascades with several steps are my favorite subject of research. Then there's some synergistic impacts here of the fragmentation. We have a synergy among the mining impacts, invasive species, and climate change. Invasive species are really good at responding to climate change and fragmentation. So we would have a synergy there, especially with something like red maple. Loves the warmer climate, loves the fragmented landscape. Factors reinforce each other. These three factors in particular would reinforce each other and add large impacts inside the boundary waters. So the boundary waters, it's a relatively pristine baseline for how ecosystems respond, and you may not know this, but the boundary waters among scientists is famous around the world. I have published a number of papers on the boundary waters that have been cited by 1,300 other scientists from 57 countries around the world. And so the boundary waters is a famous worldwide baseline for how a natural ecosystem functions that we can use to compare to the rest of the landscape that is managed by humans for timber production or other purposes. And without a baseline, science doesn't mean anything. So I think to me as a scientist, that's probably the most important point about the boundary waters, is that it's a world-class baseline. And with that, Becky is going to cover the last few slides. If I can get this off. There we go.